Hello everyone, I'm Anushya. Today we are going to study about the subject wireless cellular communication based on the topic CDMA. So in the previous videos we studied about the introduction on CDMA, its network architecture, network and system architecture, and we also saw some of the channel concepts of CDMA. Now we are going to study about, in this video we are going to study about the CDMA system operations, that is layer 3 operations and 3G CDMA. To begin with, first let us know what is the CDMA layer 3 operations. We know the purpose of this GSM cellular system and CDMA. The operations are handled with this. What are all the operations that can be handled by the CDMA systems also? Since there is a substantial commonality between the GSM and the CDMA systems for operations that support a subscriber's connectivity and mobility, and since a great deal of detail which was seen in this GSM, this would emphasize that the CDMA system can work with two different two different, that is with the addition of FDMA as well as TDMA. The cellular the CDMA technology drives some of the differences, drives some of the differences between the other the GSM technology. The advantages are better immunity to interference and multipath propagation. The frequency reuse factor for this is frequency use factor of n equal to 1. The ability to perform soft handoffs and extremely precise power control. These are all the advantages of CDMA on GSM technology. The CDMA technology based cellular and PCS systems, the operations that can be covered in anything other than general terms, could be done by using your CDMA. Now to begin with, let us start with the layer operations. As we can see in this slide, we have the initialization part and various steps that are involved during the state transition of initiation of a call. So let us have a look, let us study the individual steps that are involved in the initialization of a call. So first, to begin with, initialization, or even it is also called as registration. CDMA system registration procedures are dependent upon the status of the mobile station. The mobile may be either in a detached condition or in an attached condition when first turned on. The mobile goes through a power-up state during which it selects a CDMA system and then acquires the pilot and the synchronous channels, which allows it to synchronize its timing to the CDMA system. When attached, the mobile may be in one of the three states: the mobile station, idle state, maybe it could be in the idle state, the system access state, or the mobile station control on the traffic channel state. So these are the three different states it can undergo. Now, after the initialization or the registration state, we have that is I said there will be three states. One is idle state. So while in the idle state, the mobile monitors the paging channel. In the system access state, the mobile station communicates with the CDMA base station, sending and receiving messages. So that is we can see here in the slide. And later on, in the mobile station control on the traffic or the traffic channel state, the mobile communicates with the base station using the forward and the reverse traffic channels, while in various traffic channel substates, The registration is the process by which the CDMA mobile station, through messages to the base station, informs the cellular system of its identification, location, status, slot cycle, and other pertinent information necessary for proper and efficient system operation. For slotted mode operation, the mobile provides the base station with the slot cycle index value so that the base station may determine which slots the mobile is monitoring. Next comes the power up registration. The mobile station registers when it powers on switches between different band classes or either PCS frequency blocks, alternating operating modes, or analog and CDMA operation. Now coming to the power down registration. The mobile registers when it powers off. It has previously registered in the currently serving system. Timer based registration. The mobile registers whenever various timers expires. This process forces the mobile to register at regular intervals. Distance based registration. The mobile is forced to register whenever the distance between the current serving base station and the base station where it last registered exceeds a current threshold. Next comes the zone based registration. The mobile station registers when it enters a new zone. Registration zones or groups of base stations within a particular system and network. Zone registration causes the mobile to register whenever it enters a new zone that is not on its internally stored list of visitor registration zones. Next comes the parameter change registration. The mobile station registers when specific parameters stored in its memory change or when it enters a new system. This form of registration is independent of roaming status. Ordered registration. The mobile station registers when requested to by the base station through the issue of an order message. Implicit registration. Whenever the mobile station successfully sends an origination message or a page response message, the base station is able to reduce the location of the mobile. These circumstances are considered to constitute an implicit registration. The last but not the least, traffic channel registration. Whenever a base station has registration information for a mobile that has been assigned to traffic channel, the base station may notify the mobile that it is registered one. Next come how the call. Then after knowing the registration process, let us see how the call establishment is going to happen in the CDMA technology and the channel probing concept. During the call establishment state, as we have seen already, the initialization state, that is whatever, in the initialization state, we have three states. One is the idle state, access state, and the memory state. Once the mobile has achieved the initialization, it moves into the idle state. What is that is going to happen in this idle state is the mobile is waiting to receive the calls or data messages, or it is ready to originate a call or some form of data transfer. Can support subscriber connectivity and mobility. The mobile is constantly monitoring the radio channel quality, recording paging channel messages to obtain system parameters, access parameters, and a list of neighboring cell sites to monitor. Next comes the access data. The CDMA mobile will enter the access state when it receives a mobile directed message requiring an acknowledgement, originates a call, or is required to perform registration. When in the access state, the mobile will randomly attempt to access the system. Access to the system is obtained when the mobile station receives a response from the base station on the paging channel. Since the multiple mobiles may be associated with a particular paging channel, they may simultaneously attempt to use the same access channel. The resulting signal collisions at the base station will most likely result in few, if any, of the requesting mobiles being granted access to the system. Therefore, to elevate this problem, some form of collision avoidance scheme is necessary to increase the probability of a successful system access by a mobile. For the CDMA system, this access control or protocol is implemented through the use of the access class groups. We can see here in this slide we have showing this access attempts, where we have the access probes 1, 2, access probe 3, access probe sequence n, like this. So what this actually access probe is going to do, as we have seen in the access state, collision is going to happen. So to overcome this, how the access probes are going to work. CDMA system, this access protocol is implemented through the use of access class groups with assigned priorities. So these probes are assigned with the priorities. A gradual increase in access request power level, random time delays for access requests, and a maximum number of automatic access attempts. So the transmission of a series of access probe sequence is known as access attempt. Each access probe consists of an access channel preamble and an access channel message capsule of 3 or 10 frames. This yields an access probe with a duration of 4 to 20 millisecond frames. Two types of access messages may be transmitted by the mobile on the access channel. Either a response message or a request message could be sent through this access channel. Next comes the traffic state. The other state. The mobile enters the traffic state when it begins to transfer user information between the mobile and the base station. For the GSM cellular system, for the GSM cellular, this information can be voice or data that originates from the PSTN or PDN or another mobile in the same or another network. While in the traffic state, the mobile transmits voice and signaling information on the reverse traffic channel and receives voice and signaling information on the forward traffic channel. Signaling over the traffic channel can be performed by either a blank and burst or dim and burst process. The blank and burst signaling method replaces 1.25 millisecond of speech data with signaling message burst. The dim and burst method inserts signaling message when speech activity is low. Next comes the mobile originated call. Now, what is this mobile originated call and mobile terminated call? Okay, so let us have a look at the mobile originated call. So this is your mobile originated call timeline. Now, to originate a call, the mobile sends a system access message on the access channel and then monitors the paging channel for a response from the system. If the access is successful, a forward traffic channel is assigned that corresponds to a particular voice code, and base station receiver is assigned for the reverse traffic channel log PN code. Additionally, the base station sends a paging channel message, the mobile with the voice code information, and a reverse traffic channel assignment. The mobile configure itself and begins decoding null traffic that the base station has started to transmit over the forward traffic channel. The mobile starts to transmit a preamble and the mobile responds by starting to send traffic. So this is what is shown in the slide. The steps in timeline chart form. During the call, there are constant power control operations taking place, and if the mobile is moving about, handoffs may occur between different base stations. Next comes the mobile terminated call. So this is what is the originated call timeline. Next comes the terminated call. For a mobile terminated call, the base station sends a message to the mobile saying that for the paging channel, if attached to the system, the mobile sends an acknowledgement response on the access channel. The base station receives the acknowledgement, configures a forward traffic channel, and assists a receiver to mobile's reverse traffic channel. The base station begins to send null traffic on the paging channel and sends a paging channel message containing voice code and RTC information. The mobile configures itself and begins decoding the null traffic and transmitting a preamble on the RTC. The base station acknowledges the preamble and preamble sent on the RTC. The mobile receives the acknowledgement and begins transmitting null transformation. The base station sends an alert message for a ringtone and display of calling number information. The mobile acknowledges the message by ringing the handset and displaying the calling number. When the subscriber answers the incoming call, a connection message is sent on the RTC. The base station acknowledges the connection message and begins to send traffic. So this is what is done is the originated call timeline. The next concept is the call handoff. Moving on for the next concept, we go for call handoff. But now, before going into this, now let us understand what is call handoff. So, as we have seen, there are there are few situations where the mobile stations are in the in mobility. So at that time we say handoffs are required. The procedure used and the type of handoff performed will depend on the mobile's present state. In all cases, the handoffs are mobile assisted since the mobile station is tasked with the reporting signal strength measurements of various pilot channels to the network. First comes the idle or access handoff. If the mobile is in the idle state and moves from the coverage area of one sector or cell into another sector or cell, an idle handoff can occur when the received signal strength of a different pilot channel determined to be twice as strong than the current PC. The mobile will start listening to the paging channel associated with the stronger PC. This type of handoff is considered a form of hard handoff since there is a brief interruption of the communication link, but it is certainly different from and less disrupting than a hard handoff that might occur when the mobile is in the traffic mode. While the mobile is in the access state, it can also perform a handoff. The access handoff may occur before the mobile begins sending access probes, during access probes, and even after it receives an access probe acknowledgement. An access entry handoff allows the mobile to perform a hard idle handoff from one paging control to the another in the best signal strength sector or cell just after the mobile enters the access state. Next comes the different types of handoffs as it is shown in the slide. We have the softer handoff, soft handoff, and softer handoff. Now let us look into the individual part. What is the soft handoff? In the a soft handoff occurs when the mobile is able to communicate simultaneously with several new cells or a new sector of the current cell over a forward traffic channel while while still maintaining communications over the FTC and FTC of the current cell or sector. The mobile station can only perform a soft handoff while in the traffic state a new cell or sector that has the same frequency carrier. The use of soft handoffs is associated with the near-far problem and the associated power control mechanism used in CDMA systems. If a mobile moves away from a base station and continually increases its output power to compensate for the signal attenuation encountered at the greatest distance, it will cause a great deal of interference to mobiles in neighboring cells and also raise in the level of background noise in its own cell. So this is what is soft handoff. Now moving on to the next part, that is the softer handoffs. Softer handoff. The first type of handoff is known as the software handoff since the handoff is between two sectors of the same cell. A soft handoff occurs between two different cells, and a softer handoff can occur when The motion of the mobile gives it a handoff choice between two sectors of the same cell and a sector from a adjacent cell. It is as shown in the slide. So the mobile sector is moving from one cell to the another cell, right? So in all CDMA handoff procedures, a number of base stations and their pilot channels are involved. The procedures for stopped and softer handoff controls control the manner in which a call is maintained as a mobile crosses boundaries between cells or enters a new sector of the same cell. In a soft handoff, more than one cell simultaneously supports the mobile's calls. In a softer handoff, more than one sector of a cell simultaneously supports the mobile's call. The CDMA mobile station will continuously scan for pilots and establish communication with any sector or cell that has a pilot RSS that exceeds a certain threshold value. So this is about the handoffs that is going to happen. That is hard handoff and softer and softer handoffs. Now moving on further, we have the IS95B CDMA 2000 and WCDMA. Now what is this IS95 and WCDMA? So this is IS95B, CDMA 2000 are the different types of CDMA, where the CDMA 2000 or its backward compatibility, that is, it is a backward compatibility with IS95B with support for high speed packet data and multimedia services and advanced radio technologies such as smart antennas. To achieve enhanced packet data transfer rates, CDMA 2000 has incorporated several improvements and additions to the IS95B air interface and the coding schemes employed by the system. Thank you. Hope this video would be useful to you. Thank you for watching.